podcast. I'm your host, Nick Jikomis, and today I'm speaking with Dr. Mikael Palner. Mikael is a neuroscientist based out of Denmark, and his lab is trying to understand the neuronal circuits involved in things like obsessive compulsive disorder and anxiety. So they look a lot at how stress affects animals, how it affects their behavior and their brain, how stress can lead to things like compulsive behaviors and anxiety, and they look at how drugs affect the brain and behavior in animals. In particular, they're interested in drugs that might be used to treat things like OCD or anxiety. Recently, they've started looking at psychedelics. They've looked at a variety of psychedelics, but they've published some interesting work recently about psilocybin, and his lab developed a microdosing protocol for rats where they gave them small doses of psilocybin over an extended period of time and looked at how that affected their brain and their behavior. And so they mapped out some really interesting things, and they found that microdoses of psilocybin given every other day for about 3 weeks lead to changes in behavior, and they lead to changes in the brain, changes in the expression of different serotonin receptors in particular parts of the brain, and things like that. So if you're interested in psychedelics and microdosing in particular, this is a really interesting episode. Mikael's lab has done some of the only work that's out there right now looking at microdosing in animals and really mapping out if and what specifically it's doing in terms of the neurobiology at work here. As always, if you enjoy the content I'm producing, please like, share, and subscribe. You can sign up for my free weekly newsletter at mindandmatter.substack.com. On my Substack, you'll find all the podcast episodes, links to transcripts, show notes, video and audio formats, as well as long-form science writing, which synthesizes the various topics that I tend to cover on the show. This episode is supported in part by Athletic Greens. Their main product, AG1, is a comprehensive and convenient daily nutrition product containing 75 vitamins, minerals, and whole food sourced ingredients with less than 1 gram of sugar per serving, no nasty chemicals or artificial anything. It's gluten and dairy free and compatible with paleo, vegan, vegetarian, and ketogenic diets. AG1 is a quick and convenient way to supplement your diet to help ensure your body is getting the nutrients it needs. It comes in powder form, and you can mix it in water and drink it, or you can put it into a smoothie or a shake or something like that. I mix it into water and drink it with the first meal of each day, and it's super convenient. If you go to athleticgreens.com/mindandmatter, Athletic Greens will give you a free 1-year supply of vitamin D and 5 free travel packs with your first purchase. Their vitamin D product comes in tincture form, so you just take 1 drop each day. A large fraction of the population is actually vitamin D deficient, especially in winter months when we get less sun exposure, and vitamin D is super important for the proper function of the immune system and for a variety of other things. And there's even evidence indicating that vitamin D deficiency is correlated with more severe cases of COVID-19 in those who get infected. Every time I go into the doctor each year for a checkup, I'm always told that vitamin D deficiency is very common and I should be supplementing on a daily basis. So visit athleticgreens.com/mindandmatter or click the link in the episode description. You'll get a free 1-year supply of vitamin D with your first purchase. And with that, here's my conversation with Dr. Mikael Palner.
Thank you so much for having me on the show.
Where are you joining me from?
So I'm joining you from Denmark and more closely Copenhagen, where I live. But my research lab is in Odense, in the central part of Denmark.
And what's your scientific background and what does your lab study?
So my lab studies anxiety and obsessive compulsive disorder and neuronal circuits related to that. And it's actually quite of a journey from where I started out. I started out as a organic chemist and did my bachelor in organic chemistry, and then I did a master in bioengineering, so biotechnology engineering. And from there on, I then took neuroscience and became interested in PET imaging and other kinds of whole brain imaging methods. And
so what are some of the methods? What are some of the main technologies and methodologies that your lab is using today?
So the main overall method we're using is PET imaging of small animals.
And so that's positron emission tomography?
Yes, exactly. So you have a radio labeled drug, so a drug that has a radio isotope on it that decays into electrons, and then when two electrons meet, they shoot out two positrons, and then or two photons, and then we can measure those. Or in the case with a positron, and shoots out these two photons that you can measure.
I see. So at a high level, what would be an example of how you use that experimentally in animals?
Exactly as in humans. So that's the beauty of the technique, is that it's completely translational. You use it a lot in humans, mostly in cancer research at the moment, because we have some very good tracers to discover cancer when a person comes in and they get scanned. But you can also use other compounds to study the whole brain and the brain function. And one of the most used tracers is a radio-labeled glucose derivative. So it's just sugar with a radioisotope on it. And because the brain uses so much sugar, then you can actually inject this, and then in people you can see how much sugar are you using in different areas of your brain, and then that correlates into how active is that brain area compared to other areas.
Mm. So in the case of like a drug, if you had a radio labeled drug and you give it to an animal, you would be able to visualize where exactly in the brain that drug is going.
Mm-hmm. Yes. So I spent a good time of my PhD actually developing one of the first, or being part of the team that developed one of the first, two of the first PET tracers for the serotonergic 5-HT2A receptor. So we had the first one we developed was called MHMZ, which is an antagonist of the 5-HT2A receptor. So that's a serotonergic receptor. And the second one I helped develop was called SIMBI36, which is another an agonist of the 5-HT2A receptor. So then you can visualize where are all these serotonergic receptors in the brain. If you inject this drug, it will bind to the receptors, and you can get a map of the brain. Where are these receptors in the brain?
And so what kind of spatial resolution do you get with PET imaging? Can you see down to the level of individual synapses, or is it more coarse grained than that?
No, it's more coarse grained. We can get down to about 1 millimeter at best. And and my lab and we study rodents and rats primarily. So the resolution isn't super great, but it's more functional and molecular than other techniques. So when we can see, for example, the 5-HT2A, the serotonergic receptor, we can also compete with other drugs, and then you can actually see, if I have this drug that binds to the receptor and I give this other drug that also binds to this receptor, then they will compete for binding, and then you will see a decrease in binding over time if they compete with each other. So that's actually really useful if you want to figure out, is this drug going to the brain? Is it binding to the right target in the brain? Yeah.
I see. Yeah. So by giving both of those things and using the PET imaging, you can see to with some spatial resolution where the drug is going, but then you can also measure how much it's occupying a given receptor.
Exactly. Yeah. And if you have the big regions like frontal cortex, you don't really need a lot of resolution. You will still be able to quantitatively measure how many receptors there are and how much is this drug occupying different kinds of receptors.
And so you said your lab studies anxiety. From a neurobiological perspective, can you just talk a little bit about what is anxiety, and what sort of purpose? Why do animals feel anxiety?
It's quite interesting, because if you look at anxiety and in animals, you actually have neurons sitting that are responsive to different kinds of anxiety. I always use this example from people that have been looking at the fear of heights in mice, and they lifted up the mouse from the table, and then they saw certain neurons in the amygdala was firing when they lifted it up high, and when they didn't lift it up, they were not firing. So you have these receptors sitting in the amygdala, or neurons sitting in the amygdala, that are responsive to different kinds of dangers in your environment. and they try to predict if things are dangerous for you. And then they tell the rest of the brain, this could be potentially dangerous, you have to look out. And then if you go a step further and you, for example, are experiencing post-traumatic stress syndrome, then it's a different kind of a thing that goes on. You have a conditioning. So if you have Ivan Pavlov, the famous Russian psychiatrist who did this experiment with dogs, where he had wanted to feed his dogs on the same time, or at the same time, he had many dogs. Then he was ringing a bell, and then he noticed that the dogs were actually starting to drool before they got fed, just by hearing the bell. And that's called a conditioning. So we can do that in anxiety research as well. You can look at something called fear conditioning, where you then prime an animal to the sound of a noise and to a food shock. And then after a while, it will respond to the sound of the noise as if it had the food shock, but doesn't get the food shock. And that's kind of some of the same things that are going on with if you get PTSD, for example. If you are a soldier going out and you are in a stressful environment and you get a fear response, and then you couple that with something else that goes on. You could be driving past a bakery shop and smell the smell of fresh bread, and then you couple those two together, which are a stimuli that's not dangerous with a stimuli that is actually very dangerous, and then they get coupled together.
And so when we think about things like stress and anxiety in the brain and how they're generated, what are some of like the brain regions and the circuits that you've looked at or that you've studied that are important for either creating or getting rid of anxiety?
Amygdala is generally seen as one of the most important areas, but actually hippocampus, we know, is a region that is really important in retrieving and storing memories. So that also plays a big role. And then all of the frontal cortex is really, really key, because you can actually control a lot of your own anxiety just by convincing yourself that there is no monsters under the bed, because I have never seen a monster. That's what I told my daughter a couple of minutes ago. And then you can reason yourself into believing, okay, if I never seen a monster, why should there be a monster under my bed? And then you can actually lower your anxiety in that way. So the frontal cortex has a lot to say.
I see. So the frontal cortex can provide a different kind of feedback to these other circuits in places like the amygdala that you might say are more responsible for generating the anxiety, but the frontal cortex is maybe involved more in inhibiting that response as you learn what actually is or is not dangerous.
Yes, or also the other way around. It can also be the region that tells you that a lot of things that isn't true, for example. Or if you have obsessions, you will also get them generated in some areas of the cortical regions, and they will go down and then become ruminations and obsessions.
And that, I mean, I think that probably ties into the work that you do for obsessive compulsive disorder and compulsive behaviors in animals. So how do we start to think about that? Why is it that my understanding is animals will often show compulsive behaviors, not always, but oftentimes in response to a strong stressor or in response to chronic stress. And so what is that relationship between stress and anxiety on the one hand, and these repetitive compulsive behaviors that you sometimes see?
Yeah, you notice repetitive behaviors in many animals. If you go to an old zoo where they don't have enough space, you will see they go around in the same circle all the time. But we can also measure that in less stressful ways. They will also groom. So you can, if you induce obsessive compulsive disorder, they will actually groom so much that their hairs are they lose their hair. So you can watch this innate behavior that I kind of I put it in the same box as humans are checking their phone. So you are checking your phone, there's no notifications, but you do it anyway because you're bored and you just check it. The same thing, rodents will just, if they sit in a corner and they have nothing to do, they will just groom their fur and have a nice time about it. And then you can see if that goes up it usually goes up if they're stressed. So if you stress them, then they will groom more. Or if they are less stressed, it will usually go down.
I see. Is this sort of, so like grooming is basically an innate behavior. All animals have different types of grooming behavior. So, we see our cats and dogs doing this all the time. Mice do it. We do it, and immediately when you think of something like OCD, right, you think of classic examples like someone obsessively washing their hands over and over again, or you just think about someone who, bites their nails when they're feeling anxious. These are all
Or,
sort
there's
of
even studies that have shown that if I start to talk to you about lice or something, then you will start to actually begin to touch your hair and and scratch, and you will do that more if I talk a lot about that. So yes, you can induce it in humans as well, actually.
Hmm. And how do we start to think about this? Is maybe one way to think about it that like grooming behavior is sort of inherently or innately um, it reduces anxiety. It feels, animals presumably feel good, or feels good when we wash ourselves, we get clean, we groom ourselves. Is it sort of a natural anxiolytic behavior, and that's maybe why it gets coupled to stress and anxiety responses, because it's sort of a behavioral attempt of the animal to ameliorate whatever stressor it's encountering?
That could be really nice if we could ask them and figure that out.
Mm-hmm.
It could be, yeah. So if it feels good and you can lower your anxiety by doing something or stress that feels good, that it could be a natural way of lowering your own stress level.
And so how do you measure in animals something like stress or something like compulsive behavior? What does that look like experimentally?
We video record their grooming and then we assess how much they groom. But then at the same time, we also do other kinds of animal behavior measurements, like having an elevated plus mace, for example. That's a big X where they're lifted up from the ground, and you have two arms that are closed and two arms that are open, and then you can measure how much are they actually venturing out in the open space compared to being in the closed space, and then you can see if they are more or less anxious. The same thing you can do in a big square, where you can see how much do they venture into the center of the square compared to how much do they venture out in the corners of the square. But
Mm-hmm.
then we also use PET imaging and looking at some of these circuits for compulsive behavior. One of the circuits is called the corticostriatal thalamocortical circuit. And you have, as I said before, you have the cortical regions that are giving a lot of signals down to another region in the brain that's called the striatum. And down in the striatum, you have two principal kinds of neurons that respond to dopamine. So they're called the dopamine D1 positive neurons and the dopamine D2 positive neurons. And they are actually sending signals down to the midbrain. And the really interesting thing here is if you turn on one of these, then you will also turn on grooming. But if you turn on the other one, then you will lower grooming. So these
Mm.
two, the ratio between the turning on and shutting down of these two pathways are actually very much involved in grooming behavior.
I see. So then I would imagine that the levels of stress or anxiety that an animal is facing are going to tune that ratio somehow.
Yeah, you will definitely get some dopamine release into that whole thing, and then you can actually see how much are they binding to the D2 and D1 receptors, and how much grooming are they doing, and this dopamine release will be also a kind of a stressor for the
Mhm.
animal.
And so in humans and in animals, when you have something like obsessive compulsive disorder, what are the most effective treatments we have in terms of drugs that are used? How well do they work, and what are they doing? What is their what is like their pharmacology?
Yeah, right now, unfortunately, we don't have very many options. The most prescribed one is serotonin reuptake inhibitors, SSRIs, or antidepressants. And then you give them in a very high dose for the obsessive compulsive disorder. So they actually have a lot more side effects than reported than people with depression normally do. And a lot of the time, they are not really that effective. So they can lower some of the anxiety, but they don't really do anything about the obsessions and the thought patterns you get. Then, so in the new drug realm, we're seeing some papers coming out with the psilocybin and this psychedelic drug, and seeing that this may be a way to ameliorate some of the symptoms of obsessive compulsive disorder.
And so, I mean, have very many studies been done demonstrating that, or is that something mostly that people are reporting anecdotally at this point?
Hasn't been a lot of studies. It's mainly anecdotal, but back before psychedelics and psilocybin was a thing, the first clinical study that actually came out was from some people, Moreno et al. I can't remember his first name, but they studied OCD with psilocybin and showed very good effects on that.
When was that? Was that quite a while ago?
That's in 2008, I think.
Oh, okay. Okay, so there's some indication here in the literature, some hints,
It's
and
also two clinical trials going on right now, so there are a little bit of things going on. Yeah.
yep. And so so there's some reason to think that psilocybin could be effective for treating compulsive disorders, and you guys have started to study it, yes?
Mhm. Yeah. Both in high doses actually, but also we recently published a paper on microdoses of psilocybin and looked at the compulsive behavior and anxiety and stress levels.
So what is the phenomenon of psychedelic microdosing, and what have people been saying about it?
The phenomenon really took off in Silicon Valley in 2012 to 14-ish, where a lot of people were trying to get in on this productivity wave of being focused and productive in the tech environment. And then they took up taking small amounts that are non-psychedelic of psychedelic drugs. And that could be both LSD, that could be psilocybin, or other types of psychedelic drugs. And they would take them, often they would take them every second or every third day. And then they would report benefits to focus and stress. And basically, the internet was starting to blow up with good things that could happen when you microdosed. If you feel you can get better from this, you can probably find somebody who said they got better from it. So there was a lot of reports, and it wasn't really clear what it was doing. So I got excited about it a little bit and thought we have to figure out what is what in this story. Usually when you have so many positive stories and anecdotes, there is some truth to it. You just have to figure out what it is. So we started to study that in rats, and then came out with some positive results recently.
So before we unpack your work, has any work on microdosing been done in humans? And if so, what has that looked like so far?
There's actually been quite a few studies, but they're mostly retrospective studies. So they have been like questionnaires or looking at Reddit and seeing what people have reported. And from those studies, you have seen a tendency to a positive mood and somehow mixed feelings with anxiety. And then a lot of people have also reported a positive improvement in compulsive behaviors. Then there's been a few studies where they have looked at one or two doses of very low doses of psilocybin in humans, and they have measured a lot of things. And that actually seems that if you take a sub-perceptual dose of psilocybin, you actually get impaired working memory. So it doesn't improve your focus, and it doesn't improve your working memory, at least not while the drug is working.
I see.
It also makes sense in my head. I don't know if people have tried psilocybin and tried to do a Sudoku at the same time. It probably doesn't work out very well. So if we are going to take the premise that a small dose of the drug does the same as a large dose of the drug, just less, then it makes sense that you're not
Yeah.
gaining anything and
Yeah.
not gaining focus from this.
Yeah. But a couple things could could be true in theory, right? The small dose might not do the exact same thing as a large dose. That's very common with psychoactive drugs, that different doses do very different things sometimes. It could also be that, right, if you're chronically administering a low dose of the drug every second or third day, the benefit might not actually come with the acute drug effects.
Yes,
it could be some other effect that you measure in the intervening time.
Yeah. So what we did in the study was also looking at. We didn't look at the acute effects, so we looked at all the effects that were happening 1 or 2 days after we ended the drug treatment. So maybe we want to go. Do you want me to explain the study first, and then we can go into the details of what we have done? Because I think
let's do that. So just starting out, like, so you're going to give microdoses of psilocybin to rats. What is a microdose compared to a macrodose for a rat? And how are you guys determining what dose you should be using and whether or not it's a microdose?
Exactly. We can't ask the rat if it has a big trip or doesn't feel the effect of psilocybin. So we actually had to rely on what I developed during my PhD and earlier using the PET tracers. And then we had to give psilocybin and give this drug that was a radioactive drug that was binding to the 5-HT2A receptor. And if we give a large dose of psilocybin, we can see that it almost competes out the drug or the radioisotope completely. So we get a really big drop in the binding of the radioisotope and don't see any of that in the brain. So we can calculate how much do we need to occupy the receptor in order to have just a small dose of the drug of psilocybin binding to the same receptor.
I see. So
does that make sense?
Yeah, you can give this radioactive drug to the animal. It doesn't do anything in terms of like psychoactivity. It allows you to see where in the brain this thing is going. In this case, it's a drug that binds to the serotonin 2A receptor, which is the same one that's going to be responsible for the psychedelic effects of psilocybin. So then what you guys do is you can give different doses of psilocybin, and the higher the dose, the more it competes with that radio-labeled ligand for the 5-HT2A receptor. And so by looking at how much of that signal goes away, you can see exactly how much of the receptor is occupied by the drug. And I guess by using that approach, you can settle on a dose where the animals don't probably show obvious behavioral signs of tripping or whatever. And also you can calculate literally like that only a small percentage of the receptors are being occupied by psilocybin.
Yeah, the good thing was that one of my friends, Martin Madsen, did a study in humans in the exact same way. And there they were looking at the occupancy at the 5-HT2A receptor of psilocin. And then they were asking them questions at the same time. How intense is your psychedelic experience? And then they could correlate the occupancy with the psychedelic experience and figure out what is the threshold of occupancy towards psychedelic experience. And they figured out that if you have below about 20% occupancy of the receptor, then you don't really have a psychedelic experience. So we used the data from humans, and said, okay, we need to be below 20% occupancy in the rat in order to not have it as a psychedelic dose.
I see. So you give a low dose, it's below 20% serotonin 2A receptor occupancy. When you give that dose compared to a larger dose, what differences do the animals display behaviorally?
So if you give a high dose to rodents, and mice in particularly, they will make a really nice behavior that is shaking their head, called the head twitch response. Rats do the same, but not to the same extent. But we can still measure it. And if you give a high dose, they will do a certain amount of, it's called wet back shakes in rats. And then they will shake their body like having a wet dog that shakes their back.
Yeah.
And you can count that. And then when we give a low dose here, we don't see that behavior. So we are not inducing any psychoactivity on the rats at this level.
I see. So you can measure behavioral differences directly. You can measure the serotonin 2A receptor occupancy of the drug. And then you also know from the human studies that, below approximately 20%, people don't report psychedelic effects. And so all of those things sort of match up.
Yes. And then we have a non-psychedelic dose in rats,
Yep.
that we can use to treat them with over a period of time. So we chose to treat them for 3 weeks because we knew from the literature that some of the positive effects of microdosing weren't seen until at least a couple of weeks. So we chose to treat them for 3 weeks, and then we looked at behavior following the end of the 3 weeks.
And is this one microdose per day?
It's one dose every second day.
Every second day. So every other day for 3 weeks, the rats are getting a microdose of psilocybin. And
that was basically also just, we had to choose between every second day and every third day. And the rats have a little bit faster metabolism, so we thought that every second day would be good.
And then, so in what context were you doing this? What kinds of experiments did you do, and what did you see?
Following the 3 weeks, we did the elevated plus maze that I was just talking about before, where you can have the look at anxiety, and then we were looking at the open field test, where the animals are running around in the corners or venturing into the middle, and we can also measure how much they're grooming at the same time. And then we did another test that's called a sucrose preference test. So that means that you present the animal, you teach it to like sucrose water. That is 1% sugar in normal drinking water, and they tend to really like it once they get to know it. And then you present 2 bottles to them, and then you present them for 12 hours, and they have the free access to the 2 bottles of water, and then you can see how much do they drink. And usually they drink 70% of the sucrose water and 30% of normal water. If they then start to not drink sucrose water, so go down in sucrose water, preference over normal water, then we say that they have an anhedonic phenotype. That means that they are not feeling pleasure in the same way as they used to.
I see. So anhedonia would be, not seeking out pleasure as much as you normally do, and that would be that's something that's associated with like major depression, say.
Yes, exactly.
I see.
Or stress in general, or other types of psychiatric diseases as well.
And so what were the basic results in terms of the effects of this 3-week every other day microdose treatment?
So here we didn't see anything actually when we gave them a microdose, and that was good because we hope they wouldn't get anhedonic. But what we did see was that in the control animals, where so you got to remember, we are injecting psilocybin or saline under the skin, because we're not feeding them through the mouth. So we're injecting
that's
the
probably
same
stressful.
dose. That is a stressful experience. So if you have every second day has an injection under the skin, it will hurt a little bit. It will be stressful. It's not something they like. But then we see that the animals that are getting saline are actually getting anhedonic and doesn't prefer the sugar water over the normal water anymore. And the microdosing animals doesn't care. They actually prefer them at the same amount all over the time. So they don't get the same effect from the stress that we are inducing to the animals as the control animals do.
I see. So in your hands, the microdose of psilocybin seemed to protect against just the stress of the experimental conditions themselves.
Exactly. Yes. And that may also be why we don't see anything when you do this in animal or in people. So you don't get less stressed, but you don't get as stressed from stressors.
Yeah.
Right. So
it's a subtle but important difference. Yeah.
Yes.
I see. Yeah. So you would have to, if this is a robust effect, you would have to, when you make these measurements, whether in humans or animals, you actually have to give them some kind of stressor to see how resilient they are.
Yes, exactly.
And did you any other differences between the two groups?
And then following that, we were looking at the compulsive behavior, and particularly we were looking at the grooming, because we know that was a part of the compulsive actions of a rodent. And here we saw that they had a lower frequency of grooming, but they groomed the same amount of time actually, but they were just not doing it as often. as the control animals.
I see. So like a normal animal, every so often, every few seconds or whatever, it will groom and it'll say scratch itself, I don't know, 12 times on average. And it might do 10 little 12 scratch bouts per hour or something. And so every
Yes,
time they groomed sort of the same way, the same amount, but the frequency of grooming events decreased in the microdosing.
exactly. Yes. And that is very tied to, as I said, we had dopamine before, but also to stress. So we know that if they are more stressed, they will groom more. If they're less stressed, they will groom less. So it could be an effect of the stress, but it is also an effect, just a positive effect on compulsive actions of the rat that we see. A very light kind of compulsive action. So we haven't measured repetitive tapping. You can measure that on a lever press. So if they learn to press a lever press, and you can measure how many times do they do that, they can go around and just press it compulsively at the end, or run in circles. Or some mice are actually doing somersaults just all the time.
Oh, wow.
But those are really big compulsive behaviors that you can induce with drugs and stuff like that. But here we were just looking in normal animals actually, and saw a reduction.
Mm-hmm. And then, you have these behavioral differences that you can see that are related to things like stress and anxiety. Did you look at anything inside the brain? Like was anything changing inside the brain?
Yeah, that's the good thing about working with animals, is that we can actually take out the brain afterwards, and then we can look at specific markers in the brain. And we looked at most of the serotonin receptors and the receptor levels in the brain. So we looked at the 5-HT2A receptor, because we know if we give a drug repeatedly, if you take high doses of a psychedelic drug repeatedly, then you will have a down regulation of the 5-8 or the 5-HT2A receptor that they are targeting. Mm-hmm. So it will down regulate over time.
And that's presumably why, people who take psychedelics recreationally, if they take a psychedelic dose of psilocybin, say, they need to take a lot, they report that the effects are diminished for some number of days afterwards. And presumably that's because of this effect where the large dose causes your cells to get rid of some of those serotonin receptors for a while.
Yes. Yeah, it's called tolerance. You build up tolerance to the drug, and you need more and more and more in order to. But we measured that, and with this microdose regime that we see here, we didn't see any of this buildup. They actually had the same amount of receptors afterwards. They also had the same amount of head twitches if we gave them a high dose afterwards. So we were fairly certain that there was no tolerance buildup at this level. Then we looked at other kinds of receptors as well. I didn't really see much until we looked for the 5-HT7 receptor in the thalamus. So inside the thalamus region, it's also part of this corticostriatal thalamocortical circuit that I talked about before. So that's why we went and looked in the thalamus. And we know that it's involved in sorting out what to do and what to act on, and sorting out what kind of senses come into the brain and what kind of senses should we do something about. So it's kind of like a filter for the brain. And here we actually saw an increase of these 5-HT7 receptors. And the 5-HT7 receptors is sitting, so if you have two neurons that are connected, then you will have the transmitting neuron ends up in an axon that then meets in a synapse. And the 5-HT7 receptors are sitting on the end feet of these axons, and then controlling how much is released of neurotransmitter.
So the serotonin 2A receptor is different in that respect. It tends to be on the dendrites, on the receiving neuron. You're saying the 5-HT7 receptor tends to be on the sender neuron, the axon terminal of the neuron sending a signal to another one. And what do we know about 5-HT7 receptors? What are they linked with?
We don't know much about them, other than some of the new antidepressive drugs actually also have 5-HT7 affinity, so they're also binding to these receptors, and they do seem to be better than the old generation of antidepressive drugs. But other than that, we don't know a lot about it, other than it's highly expressed in the thalamus and not a lot of other places in the brain.
Okay, and you said after the so after the every other day 3 week microdosing psilocybin protocol, you saw, did you say you saw a reduction of expression of this
No,
receptor?
we saw an increase in
Increase. Okay.
yeah.
And is that,
We
were you able to tie that to behavioral changes at all?
we didn't look at correlation between these two things. I don't think we have enough animals to actually say something about the correlation between those things. We have in this experiment 16 in the biggest group of animals where we did both measurements. But we did tie it to another marker of synaptic plasticity that's called the SV2A, which is
Hmm.
a synaptic vesicle 2A, which is sitting in the axons as well and help put neurotransmitter back into the vesicles before it's going to be released into the synaptic cleft. And this kind this target is also upregulated in these animals in the thalamus, but not in the cortex and not in the hippocampus.
I see.
So we can actually see that the effect here in the thalamus is actually pretty robust because we have two markers that are going in the same direction.
Hmm. And so I would say overall, it sounds like, so you've established a sort of bona fide microdose in rats. It doesn't give the behavioral effects that a larger dose does. It doesn't result in tolerance. You've measured the receptor occupancy of the drug and you've kept it under a certain amount. So it's a real microdose, it seems. And doing that chronically for 3 weeks every other day gives you both behavioral changes that you can measure in what the animal's doing, as well as these molecular changes in receptor expression at synapses. And so something is clearly happening in the brain in
Mhm.
response to a microdose. What do you think that makes it more plausible than it was before that something is actually happening when humans are microdosing?
I think something is happening. It's a matter of if you can feel it. I think so. Think about it like this: if you are perfectly happy and going around your day and not really getting a lot of stressors on your life, and you are yeah just normal quote or happy, then I don't think you will see a big effect because you're not getting all this stress into your life and getting the stressors in. But maybe if we find some patient population or some population of people where they are really they're feeling a lot of stress and maybe they're feeling the stressors more than other people, I think in that uh, portion of people it may be effective to a higher degree than in other people.
Hmm. Yeah, I mean, it might, this is speculation, but maybe
Yeah,
that's why this was like a Silicon Valley thing because, you've got people over there, working all day in a stressful environment and trying to do lots of difficult things. Maybe it's not a coincidence that that was the population that seemed to gravitate towards this.
it's actually interesting now. I'm doing some talks about microdosing as well, and so I digged into when the first microdosing experiments were actually happening, and I believe that it is as old as psychedelics because if you look at the Native Americans, they were using peyote as as their psychedelic experience. That and those peyote buds they have mescaline in them, and you actually need to have 10 or 12 peyote buds to have a full dose of mescaline
Hmm.
to have a psychedelic trip. But what they were doing during the day was actually just going around chewing one when they were going hunting and stuff like that. So I think if you're chewing one peyote bud, that is probably equal to a microdose.
Hmm. Yeah, and if it's having some kind of stress resilience effect, then it might be useful in that kind of context.
If you haven't eaten for a long time and are out hunting and trying to find food enough for your family and stuff like that, so they traced these peyote buds and the use of these peyote buds back to 5,700 BC. So it's been used.
Yeah, people have been using this stuff for a long time. Wow. So, what are you guys doing now? To what sort of how are you going to build on this set of experiments?
Actually, we have quite a few studies with that are not published yet, but with high doses of psilocybin in rats as well, and trying to look at some of the same circuits and also see see changes in the thalamus as one of the big regions when we treat the animals with a high dose of psilocybin and then wait a week and then trying to look with PET scannings and see how are the circuits developing, where are the different changes in the brain happening, and we look at the thalamus and see that stuff is going on there as well with a high dose. And then yeah.
Oh no, I was just going to say, so when you saw these changes in the paraventricular nucleus of the thalamus, did that surprise you? Were you expecting to see something in that particular region, or was it kind of a surprise?
It was a surprise to us that it was in that region. We were deliberately looking in the regions that were part of this circuit that compulsive actions were made of, because we know that was where we were going to look if we saw an effect of compulsive actions. So up front, we were going to look in the thalamus, and then the frontal cortex, the striatum, and those regions.
And then, it sort of sounded like you were saying, you found this change in the 5-HT7 receptor in this particular region of the brain. It sounded like you guys looked for all sorts of different changes in different receptors, but you didn't see, many of them didn't show a change. Is that a fair summary?
Yeah. We didn't see changes on the 5-HT2A or 5-HT2C receptors. We also looked for the 5-HT4 receptors and didn't see anything. I don't think that's in the manuscript, but we didn't see anything. We also didn't have any affinity to the 5-HT4 receptors. So we looked at a lot of different things. And then now we have also begun to look at other types of psychedelic drugs and looking at if we can actually figure out, because psilocybin is it's gained status as the gold standard of psychedelic drugs, more or less, right?
Mm-hmm.
If we go on in the world, probably if we're going to do a comparison between two drugs, like psilocybin will be one, and then you're going to compare to another one and see which is better. So we are starting to look into some of these drugs and just looked into. Ones? Yeah, we just looked into a form of ayahuasca, but doing it with pharmaceuticals, so it's called pharmahuasca. Mm-hmm. We mix the marrow inhibitor with DMT, and then we try and see the effects on the brain, and see if we get increased DMT in the brain when we mix it with the marrow inhibitor. That's those two drugs are usually the ones that are combined in ayahuasca. And yeah, for the first couple of experiments, we did a pilot study just to see if we could increase DMT in the brain by mixing these drugs together, and that it seemed to work fine. So now we can pass on and go on and experience that kind of cocktail a little bit more.
Interesting. Are you doing anything with mescaline?
Not yet. I really want to do something with mescaline. We have done studies with LSD, 5-MeO-DMT, and DMT, and 4-hydroxy-DIPT also. And mescaline, we want to, because it's a different kind of structure. The drug has a different kind of structure. But I don't think we will end up using mescaline because it has a really low affinity for the 5-HT2A receptor. And we're going to probably have some derivatives that has higher affinity for the 5-HT2A receptor. And in that regard, actually, also a long time ago, when we developed these agonist radio tracers to the brain, we actually found one drug that had a really high affinity towards the 5-HT2A receptor and was very selective to the 5-HT2A receptor. So one of the N-bomb compounds called the 25CN N-bomb, mm-hmm. It binds really strongly to the 5-HT2A receptor, and it's really selective and doesn't bind to anything else. So
is that the one that gives people very long duration trips?
Yes, and usually also very unpleasant. Mm. And there's been a few reports of people also dying from it. So I wouldn't recommend anyone doing that.
I see. Interesting. So as opposed to the other psychedelics like psilocybin, that one is very selective for 2A.
Yes.
Interesting.
Yeah, so psilocybin or psilocin basically binds to most of the serotonin receptors, but this drug only binds to one. And yeah, people
Yeah.
report that it's quite unpleasant and other people have been dying from it. So don't do that.
Mhm. And like obviously right now, all of this work with psychedelics and related compounds, it's getting a lot of attention. People are very excited. People are Many people are very hopeful that these could be a very effective alternative to the many psychiatric medications that we use today that are not that effective or not effective as we would like them to be. How excited are you in terms of psychedelics or psychedelic derivatives turning into prescribed and widely used psychiatric medications in humans? Do you think it's a very are you very excited? Are you skeptical? Is how much of this is hype?
I'm pretty excited about it. It's actually one of the first times where we have seen improvements in treatment options for psychiatric diseases. But I also think that it comes with a lot of problems that we may have not seen before, because for these drugs to be effective, I really believe that you need to have a good therapeutic session as well. So you need to have a therapy in order for them to actually work in a nice way. And that comes with a problem, right? Because then we need to have a lot of therapists, and that is an expensive way of treating people compared to when you just give them a drug and say, go home and take this for 2 weeks and then you feel better. Then you need to start and incorporate the therapy into to treatment. But I also think that is a really good thing, because therapy by itself also helps people, right? So I think it's gonna show some really nice things in the future if we can get hold of how these two things are going to be matched with one another. And maybe you don't need to give people a super high dose. It could be that they need a microdose or a small dose that is just a little bit psychedelic, and that will be very effective as well. And maybe there's different doses for different conditions. That could also be.
What do you think are some of the key questions in psychedelic neuroscience right now that people are or should be pursuing? What are some of the questions um, that we'll get answers to, but are still big question marks in terms of how these drugs are working?
I think side effects are one of the really big ones. We simply don't know a lot of the side effects that could happen. Um, so what are yeah, how are this and psychosis related? Is it related at all? We need to know that if we need to start treating people and or not treat people that are in danger in that way. Then in case of microdosing, there's a lot more complications because we give a drug. There's a huge difference in giving a drug once and then not giving it again compared to giving a drug every day or every second day for 6 months or longer.
Mm-hmm.
So there's not a lot of people who have been doing this. There's a lot of people who have been taking high doses, and we know it's relatively safe, but there's not a lot of people who have been doing microdosing, even though it seems so on the internet. But we don't know anything about what are the long-term consequences actually of taking microdoses of psychedelic drugs or psilocybin on your health. It could be targeting the serotonergic receptors in your heart. It's actually called serotonin because it was discovered in blood, right? So it's from serum. That's where
Ah,
you discovered serotonin. So there is a lot of serotonin in your blood, and
I see.
there's a lot of
So like the etymology, like serotonin as in serum or like serotype or a word like that.
yes,
I
exactly.
see. I see. So there's a
Uh,
potential heart issue. Yeah, I've heard about this. Like apparently some of these drugs bind the 5-HT2B receptor, which is in the heart, and
yes,
other drugs that do this have been linked to
yeah,
heart
but
valve
also
issues.
just the 5-HT2A receptor will that's a vasoconstrictor, so
Mm,
it will increase your blood pressure and your heart rate when you take it, right? And we know that from high doses of psilocybin that it will do that. But what are the consequences if you do that over a long time? We
mhm.
don't know. And specifically, the 5-HT2B receptor is very expressed in the heart. And if you stimulate that, we know that from some of the weight loss compounds in the 80s that were stimulating this receptor, they got taken off the market because they were giving valvular heart disease, so it enlarged the muscles in the heart. So it could be a big issue, and people just haven't looked into that a lot. Yeah.
Is there anything that you want to reiterate or say again based on the conversation we've had so far that you think people should remember and take away?
I'm not on the top of my head, no.
So I guess the cliff notes on your experiments are, in rats, you figured out how to give them a microdose that's a true microdose. You've got clear behavioral effects and changes in the brain. So microdosing psychedelics in animals, in non-human animals, is doing something.
Yes.
It seems like it's doing something pretty interesting that could be relevant for, treating different things like compulsive behaviors or anxiety or just stress resilience, that whole sort of family of issues. And so it sounds like you said this does make you a little bit more hopeful that microdosing psychedelics in humans may be doing something. We haven't pinpointed that yet, but there could be a there.
Exactly. Yeah, that would be the take-home message of that paper. But I really also want to stress out that people should really be seeking counseling or seeking conversations with other people before just throwing themselves out into doing microdosing or high doses. It may not be a therapist or a psychiatrist. It could also be a good friend or something else, but it's really important to go out and talk about your mental health problems or issues or problems at all with other people, because that will help you in the long run and get better. So I think now, yesterday was Mental Health Day, and we should really try and be more open about our mental health in general and be better at talking about, I'm feeling stressful, or I have a bit of anxiety, or whatever it is. Then we should be better at talking about it.
All right. Well, Dr. Mikael Palner, thank you for your time.
You're welcome.
I want to take a minute to tell you about a really cool health monitoring device I've been using for several weeks. It's called Lumen, and it's a handheld, pocket-sized device with a sleek design. It measures CO2 levels in your breath, which allows their technology to determine the extent to which your body is burning fats versus carbohydrates. Lumen helps improve your metabolic flexibility, your body's efficiency in shifting between using fats and carbs. It improves your ability to burn fat, which decreases your hunger levels and makes your body less dependent on snacking, and it can increase your energy levels by helping you develop a high-functioning metabolism. I use this device in the morning, before bed, and after meals and workouts to track my metabolism. With just a couple weeks of use, I learned a lot about which foods were causing my body to burn mostly fat, mostly carbs, or both, as well as how long I need to fast each day to promote fat burning. Lumen is great for anyone looking to optimize their health for either weight loss or athletic performance. The easy-to-use app allows you to track your results together with what you're eating and how you're exercising, and it syncs with other devices like the Apple Watch. Click the link in the episode description to learn more and use the code MIND, M-I-N-D, in all capital letters to get $50 off your Lumen device today.